Hey guys, welcome to today's video. We'll be talking about torque ladder problems. First of all, I just want to go over some basic things that are important to know. Of course, you should probably know this by now, but torque is the force times the distance of like a rod or something. And in problems, I think thinking about these things helps me when I'm doing these kinds of problems. So first, it's really important to decide on a pivot point to do your problem around. And always remember the forces, they're always going to be perpendicular to the pivot point, which was kind of strange to wrap my head around. And you should separate the vertical and the horizontal forces when you're solving a problem. So here's the problem we'll be doing. A uniform ladder of length L and weight 100 newtons rests against a smooth vertical wall. The coefficient of static friction between the bottom of the ladder and the floor is 0.5. Find the minimum angle theta that the ladder can make with the floor so that the ladder will not slip. So that's the problem. First, let's go over what quantities are known. Sorry. That looks so ugly, but okay. So we know the length of the ladder, and we know the weight, which is 100 newtons. We also know the coefficient of friction, which is 0.5. So let's draw a diagram. We have our wall and the floor, and our ladder is resting on it like this. So first, we can choose a pivot point. We'll choose it here because this is where the ladder will be moving and stuff. Now we know the force of mg, the weight. We'll put that here because the weight is always at the center of mass of the object. And we also have the normal force from the ground on pushing up onto the ladder, and the normal force of the wall onto this part of the ladder. And last but not least, we have the friction force pushing this way, since the ladder will be going to the left, and the friction force is always opposite to that. Now we can separate our vertical and horizontal forces. For our vertical forces, we have the normal force is equal to the weight mg equals 100 newtons. And for our horizontal forces, the friction force will be equal to the normal force from the wall. So the normal force from the wall will be the coefficient of friction times the normal force, because that's how friction works. And this is 0.5 times 100, which is 50. So now that we have all of that, we can get started with our torques. So first of all, we can figure out the torque for mg, the weight. We know that this has to be perpendicular to the pivot point, so like if we extended the force like this, we can see that this area is the perpendicular distance. So I forgot to write that the ladder has length L, so this part would be L over 2, and so this part will be L over 2 cosine theta if this is theta. So we have our first torque is mg L over 2 cosine theta. Next, we have the normal force of the wall. Okay, so we want to find the torque of the normal force. Oops, I just erased it, of the wall. And so we know the perpendicular distance from this force to our pivot point is this thing, which is by simple trigonometry, it's L sine theta. And since it's going to the left, it's a negative force, so we have minus and the normal force of the wall, times L sine theta. And since we want the ladder to be in equilibrium, this will equal to 0. So now we can start plugging in our values and solving for this. We have that mg equals 100, and we can cancel out the l's. So 100 over 2 cosine theta minus 50 sine theta equals 0. So we have 50 cosine theta equals 50 sine theta. So tan theta equals 1, which means that theta equals 45 degrees. And that's all there is to this problem. Pretty simple after you figure out all the torque stuff from the diagram. So I hope that helped you guys. See you in the next video, and remember to sleep and study.